Getting into some proofs here, okay? And this is section, which section is it? Like 4-6 or 7? I'm not sure. 4-7? 7? I'm not sure. It's called flowchart thinking. Flowchart thinking. So, with this, we're gonna do some proofs, okay? And one way of doing proofs is with a flowchart. So I'm gonna draw a picture. Try to draw a picture that looks kind of like this. Kind of looks like a kite. And we're gonna go from here to here. Hey, that works. All right. And then I'm going to call this, I can't decide whether to wear my glasses. A race. They call this R-A-C-E. And given EC. Is congruent to AC, and ER is congruent to AR, proof angle E is congruent to angle A. Okay? So this is just a continuation of what we did the other day, except we're going to organize it into a flow chart. Okay? So if I see this, when I'm given something, usually I go through and I mark up my picture. So usually you'll have a picture, you'll always have a picture, for most of the time. Okay? And you'll mark it up. So EC congruent to AC, you mark that like that. Okay, ER is a very straightforward one. ER is congruent to AR. You mark that like that. Prove angle E here is congruent to angle A. Who could tell me how I would do that? Kind of just go ahead, Ryan.
Well, basically, since since two of the sides in each triangle are congruent and they share a side.
Yep.
Then they have the CT thing, the side. So all angles are congruent as well.
Right. So you kind of have to go through. So you have to organize it in steps. So okay, where Ryan says right, you know that they have these two sides congruent, right? So that's two sides. They share this third side over here, right? They share this side, 1, 2, 3. So you can prove that these two triangles are congruent by side, right? Therefore, angle E has to be congruent to angle A by CP, CTC. So this is the way it looks like if you organize it into a flowchart. And what they usually do is you start off with like 3 boxes, kind of like this. And on your homework, most of them in this case are kind of set up that you just fill in the boxes, but you will have to do a few on your own, okay? And so in these boxes, what you put is, first of all, what you usually put is what is given to you. So ER, that's kind of messed up. ER is congruent to AR is one thing that's given to you. And you always have to write a reason for everything you're doing. And so that is given in this case, okay? You're also given that EC is congruent to AC, and that's given to you as well, right? And then Ryan said they shared a side. What side is that? RC. So down here you do have to say this. You have to say RC is congruent to RC, right? And that is shared side or same same side. There, like back in the olden days, they'd call this reflexive prop. Oh, I wrote RS. I meant to write RC. Sorry. RC. No, RC, because this one right here, right? So RC is congruent to RC, same side, and then you put those three things together, okay? So you put those three things together, 1, 2, 3, okay, into another box. And when I put those into another box, then I could say that these two triangles are congruent. So triangle rec, REC, is congruent to triangle, name them in order. So if I name this one REC, I name this one RAC. RAC. And what's the reason for that? Matt? Oh, sorry. I thought you had your hand up. What's the reason for that? How do I know those two triangles are congruent? Go ahead, Ben. Side, side, side. Okay? So this is where you use those congruent statements for proving triangles. And then I have one more box, and the last box of your proof should usually be what you're trying to prove at the end. Okay? It should always be what you're trying to prove. So we're trying to prove that angle E is congruent to angle A because corresponding parts of congruent triangles are congruent. Okay? And that's the reason for that. Get it? Okay? So I put together my three pieces. And if you like, you can put, here's a side, here's a side, here's a side. That kind of helps you. I need three things to prove triangles are congruent, and then I could say CB, CTC, corresponding parts of congruent triangles are congruent. But if you start doing, so some people just start writing anything, you know, like, oh, CBC, CTC, they'll put that over here, or they'll put that over there. But the important thing is that you are kind of organizing your thinking and putting it together into a deductive kind of deductive argument. Okay? Can I do another one? I know you guys can't take me seriously with this hat on. Not that you ever take me seriously, but let's try another one. Okay, so here is one a little bit. This one's a tricky one. They're not. So this is really straightforward. Okay, so probably on a test or on a quiz, you'll have one straightforward like this. And then you'll have one or two that are a little more complex, okay? So let me give you another one that looks like this. First off, let's see if I can draw it, first of all. This will go like this, this will go like this. And then I'm going to draw another triangle such that this goes like this. See if that works. Good enough. Okay. And I'm going to call this A, B, C, D, E. A, B. This is point C in here. This is D. This is E. Okay? Okay. And I'm going to call this angle 1 down here. This is angle 1, and this is angle 2. Okay? And given that, given angle B is congruent to angle D, and then what else are we given? BC is congruent to DC. BC is congruent to DC. Prove angle 1 is congruent to angle 2. Okay, so this one, okay, so do I have a way that I could prove that AC is congruent to CE? Ian?
D.
Yep.
Congruent to angle D is congruent to B.
Right.
And then angle D, side DC is congruent to BC, and then angle C is congruent on each side because of vertical angles. So it's ASA.
Okay. Yeah, you can't really call it C. You could call it. Let's put a new name on it. Very good, Ian. Okay. So I'm going to call this like angle 3 over here and angle 4. Okay. So you're given, go ahead and mark up, like angle B and D are congruent, right? Angle B and D are congruent. You're also given that DC and BC are congruent. So these little pieces are congruent. And what Ian just said is I can prove angle 3 is congruent to angle 4 because those are vertical angles, right? Therefore, these triangles have to be congruent. The bow tie triangles, see the bow tie triangles? If the bow tie triangles are congruent, then that means that side AC has to be congruent to side EC. Therefore, this is an isosceles triangle, therefore angle 1 and angle 2 are congruent, okay? So you kind of have, before you start writing down stuff, you kind of have to have a plan of what you're going to write, you know? And so what this looks like in a flowchart proof, okay? You start with what you're given, okay? So I'm going to do, where's a little, is this my shape tool, okay? So I'm going to put a box here. I'm going to box here. I'm going to put a box here. I might need more room when I get here. And I'm going to put angle B congruent to angle D. D, D. I'm going to put BC congruent to DC. And both of those are given, right? Given, given. But then what's the next piece of information that I'm going to use? Ian, you said it. Angle 3 and angle 4, right? Angle 3 has got to be congruent to angle 4 by vertical angles, okay? Vertical angles, you should say like vertical angles. What about vertical angles? Vertical angles are congruent. We had a conjecture, like I think it was in chapter 2, right, that we talked about that. Okay, so we have a side, and angle between those two sides. So I could put those three things together. 1, 2, 3. Okay, and I'm going to draw a little box over here. That's not a box. Okay, let me try that again. Get a box over here. Hold on. Yes, Ben.
Wouldn't the first box be an angle instead of a side?
Oops, you're right. I'm sorry. That should be an angle, not a side. Okay, thanks. Okay, so you have ASA. That's nicer because it's in order, right? Angle, side angle. Thanks, Ben. Okay, and now I can say that triangle ABC is congruent to what triangle? ABC is congruent to EDC. Name it in the correct corresponding order, EDC. And that was angle, side, angle, right? Angle, then a side in between the two angles, and an angle. Now I put that together, okay? I'm going to use a short arrow because I'm going to need another box here, okay? To say that, therefore, side AC has to be congruent to side EC. What's the reason for that? No, that's not isosceles triangle. What allows me, if triangles are congruent, what allows me to say that side AC is congruent to side EC?
The triangle
CPCTC. That's your CPCTC. corresponding part, once this says once you've proven the triangles are congruent, all of their corresponding parts are congruent. Now I go my last step, okay, which is to say that what I'm trying to prove, that angle 1 has to be congruent to angle 2, because what's true about the base angles of an isosceles triangle? Congruent. So then you say base angles of an isosceles triangle are congruent. Okay? And that's what that flowchart proof would look like. What? Understand that? Yeah? Okay. So I'm going to just draw, I'm not going to go through all the steps for the next one. I'm just going to draw a picture of it. And we'll just kind of talk about what you do if you saw something like this. Okay? So the next one, next example, I have something, I need my glasses. Because you're going to see one on your homework like this. You have this, they love making this Z shape. And they tell you that this is parallel to this. This is parallel to this. And this C is a midpoint. And this is A, B, D, A, B, D, E. A, B, D, E. And so C, given C is a midpoint of EB, and AB is parallel, that's an A, AB is parallel to ED, prove C is a midpoint of AD. Think about that one, okay? So you're this shortcut is being really annoying. Okay, so you're given that C is the midpoint of EB. What does it tell you if C is the midpoint? What does that tell you if C is the midpoint of EB?
That EC and CB.
That this piece right here has to be congruent to that piece. Yes? Okay? You're given that AB is parallel to ED. So what does that tell you? James?
There's alternate interior angles.
Right, so you could use these alternate interior angles, this one and this one, right? You could also use this one and this one, right? Okay? Because these are parallel, so this angle here is also congruent to this angle here, right? So I should put 2 marks on those to indicate that those are congruent. So could I prove that this top triangle is congruent to this bottom triangle? By what? What is it? Angle, side. Or I could use the vertical angles and go angle, side, angle, but I already have 2 pairs of, so I could go angle, angle, side. So these triangles are congruent because of angle, angle, side. Therefore, side AC has to be congruent to side DC because of corresponding parts. Therefore, C is a midpoint. Yes? No? By definition of a midpoint. So the way this one would start out, okay, you would have a little box here. Maybe we should kind of go through it, okay? You'd have a little box. Well, I think this one is on your homework, okay? You say C is a midpoint of EB, okay? And that's given, right? But from that, you need to conclude that, okay? From that, you need to conclude that side E, that makes side EC I'll go through this. Side EC is congruent to side BC, right? I'm also given that AB is parallel to ED, right? And that's given. But I use that to make two conclusions, okay? One is that one box says that angle A is congruent to angle what? Angle A is congruent to angle what? D. Okay? And also angle E, or B, we'll call it, B is congruent to angle E. Okay? And the reason for both of those are alternate interior angle. Alt interior angle angles. Okay? You should really say, if two lines are parallel, then the alternate interior angles are congruent. So for both of these, same reason. Okay? Now I have a side, an angle. Okay? So I could now say, I could put these three things together, okay, into a box, and I can say, therefore, okay, triangle, we'll call this ABC, is congruent to triangle ABC. I'm going to call this one DEC to keep the corresponding correspondence, right? If I call this ABC, I should call this DEC. And that is angle, side, which is the same as side, angle, okay? You could either call it angle, side, or side, angle, okay? Then, now I can say that side, the reason that EC is congruent to BC, that's called the definition of a midpoint. Okay? Def of a midpoint, because if something is a midpoint, it divides a segment into two congruent parts. Now I can say that AC is congruent to DC, and that's C, P, C, T, C. And finally, in my last box, I'm going to put my last box down here because I'm running out of room. Okay? In my last box, I can put that C is a midpoint of AD. And that's kind of definition of a midpoint, but backwards, right? Because if these two pieces are congruent, AC is congruent to DC, C has to be a midpoint, so that's also definition of a midpoint. Okay, so that's about as complicated as your proofs are ever going to get. Okay? And so if you could do that one and follow that one, that's how you do it. Okay? Do you guys follow that? What I did? Okay? I wrote down what I was given. From what I was given, I was able to prove these triangles are congruent. Then I had to show that these two pieces are congruent, AC and DC. And if they're congruent, I can prove that I can say that that's a midpoint. So I just stepped on my shortcut. Okay, so that's all I got to teach you. You got 20 minutes. So a lot of these are just fill in the rest of the first 5 is just fill in the rest of the flow chart. Okay? And so I'm going to, I have it on Schoology while you're signing. Yeah, okay. So let me, postpone. My computer's going to restart in the middle of my life. Let me just see. So try to get some homework done now so you don't have to do it on Halloween. Yes. Schoology, login. Log in, I said. There we go. Go away. Courses. Come on. Come on. Flowchart proofs, 4.7. Here it is. So, that's what you gotta do. Do tomorrow. So 1 through 5 are just filling in the flowchart. Copy the flowcharts, please. Don't just write the answers, okay? So copy, you don't have, it'd be nice if you copied the picture too, but at least copy the flowcharts and fill it in. Don't just write words, all right? And